The second technique which you guys should think of is like use of fast and slow pointer. Basically, it's a kind of two-pointer approach in linked list. So in case of array, we saw that let's say if an array is sorted, you're having the first pointer on the first index and the last pointer is on the last index, right? But over here, both the fast and the slow pointer will be pointing on the head of the node. And let's say if you're having this linked list, correct? 39, 54. Now basically, let's say if this is your slow pointer is also pointing over here. Let's say fast pointer is also pointing over here. Makes sense? Now what this slow pointer will do, you will try to increment slow pointer by only one pointer. You will try to do slow is equals to slow dot next or slow arrow next. Makes sense? So now what will happen? Slow will point to 9. But at the same time, what you are trying to do, you are trying to increment the fast pointer by 2 pointer. Fast is equals to fast arrow next, arrow next. Makes sense? So can you guys tell me where will fast point now? Fast will come, fast dot next will come here, and fast dot next will come here. So now your fast will point to
50.
node 50. Is this point clear to all of you? Now let's say you are checking while slow is also not null and fast is also not null, correct? After that, what you will try to do? Now your slow pointer will get incremented by 1. Now your slow pointer is pointing to 50. Correct? And your fast pointer is pointing to fast dot next dot next. Your fast pointer will point to 300. Make sense? Fast pointer is pointing to 300 and your slow pointer is basically pointing to 50. Now since your slow and fast both are not null, again what you will try to do? You will try to increment the slow pointer by 1 and fast pointer by 2. Now let's say your slow will point over here and fast will be null because fast dot next is anyway null, right? So in the while condition, what you can do, you can check while slow is not null and fast dot or arrow next is not null. Why? Because over here, as you could see, fast dot next is null. Obviously, it is null. Null doesn't have any next, so it will throw null pointer exception. So we can check while fast is not null and fast dot next is not null. In that situation, what does the slow pointer will return you? The slow pointer is going to return you the middle of the linked list. Can you guys see this thing or not? So basically, this slow and the fast pointer technique will help you in figuring it out what is the middle element of the linked list. These all are all the tips and the techniques related to the linked list, and further we are going to discuss that in the problem. In case anyone has any doubt or concern, which we discuss till you feel free to ask me. Otherwise, we can start discussing the problem.
No, got it.
So yeah, this is the first problem you have got. Given the head of a assembly linked list, return the middle node of the linked list. If there are two middle nodes, return the second middle node, right? Let's say this is the linked list, simply return 3 as we discussed. Let's say you're having public list node, middle node is given, list node head of the linked list is given to you. You're having slow pointer is pointing to the head of the linked list, fast pointer is also pointing to the head of the linked list. And you're checking while fast is not equals to null and fast dot next is not equals to null. You're incrementing fast pointer 2 times, fast is equals to fast dot next, and slow is equals to slow dot next not next, and ultimately you're returning slow. Since you are in the question, just it is stated return the middle of the node, second middle of the node in case of event size, right? That is why you're returning slow, and the time complexity is big of it, where n is the total number of nodes in the linked list. Is it clear?
Yeah.
Okay, that sounds good. It's clear to each and every one of you. That's wonderful. Now let's move towards the next problem. We are given the head of the single linked list head A and head B. Return the node at which the two lists intersect. If the two linked lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. So basically, we are given two linked lists head A and head B. You need to return the node at which two linked lists intersect. So basically, you could see we are having list A and list B, correct? A1, A2, C1, C2, C3, and then you're having B1, B2, B3, and C1, C2, C3. So at that point, it gets intersected. Is the problem clear to all of you?
Use two hash maps here. So while traversing, we need to check whether let's say we are traversing linked list B, we need to check if that particular node is present in A's hash map. So, but that won't. So,
We can find the length of A.
no, that won't work. Okay.
No, value of next will match. That's.
I think again the fast and slow pointer can be used here.
Think more.
A difference of length of A and B, and then the difference will be traversed in the longer. linked list, and after that, whenever we find the common list node, we can return that.
We can continue storing next addresses, and at each iteration we can check in the hash map whether this hash map address is already present. So in the later, if it is present in the hash map, we can return that node.
No, try to think it in this way, right? Let's say
Can
not
we
allowed. What will you do in that situation?
can we use the previous pointer to check the C list, and if we find two pointers there, and we know that there is an intersection?
No, try to think in terms of length. Can you tell me what is the length of the linked list A?
Length of A is 5
Yes,
and length
5
of
and
B is
6.
6. Yeah, if we take the difference, then we can start the difference from B itself.
Exactly, yes, you are absolutely correct. So what we need to do over here is that we need to find out what is the difference between the length of the two linked list. Length of linked list A is 5 and length of linked list B is 6, correct? What is the difference between the length of these two linked lists? And the difference between the length of these two linked lists is 1, correct? And which has maximum length? B has got maximum length, right? And what is the difference? The difference is 1. So in that situation, what you will try to do? You will try to move one node ahead. So basically, whatever the difference is and whichever linked list has higher length, since B is having higher length, try to move that many node ahead. Since it is the difference of 1, try to move difference number of nodes starting from the head of the linked list. So you have covered one node. After covering one node, where will you come? You will point to B2. Is it clear? Now what you will do, you will try to use again a second pointer, 2-pointer approach. This is the second pointer, and then make sure you are pointing to the first pointer, correct? Keep on iterating both the linked list. Now second will increment by 1. Second will point to here, and first will point to here. Make sense? Keep on doing same thing again and again until and unless first is not equal to second. And one first and second both are equal. In that situation, simply return either first or second because that is going to be your intersection point.
But for this method, the linked list has to be connected. If the linked list is not connected, then this method will give wrong, right?
Why will it be null? In that situation, you will at any point it will not be returning anything. If this first and it is not equals, while first and second pointer are not equal, in that situation you will reach in the end till null. Are you getting my point? This is let's say first linked
Oh,
list, this
okay,
is
okay.
second linked, and ultimately you will return null, right? That is what the question is stating. Is the solution clear to all of you? Anyone having any doubt or concerns? Yes, that's what I stated, right? You need to calculate the length of the linked list before. After calculating the length of the linked list, compute the difference between the length of the linked list. And once, whenever you have got the difference, whosever length is higher, try to iterate difference number of times. And once you have iterated difference number of times, use 2-pointer approach. Try to iterate through each and every linked list once, and then ultimately whatever the intersection point is, return that intersection node value. Is the solution clear to all of you? Anyone having any doubt or concern? Okay, so I'm taking that as a no. Still I'm a counter. In case anyone has any doubt, feel free to ask me. Otherwise, we'll move toward the solution. Okay, sounds good. So yeah, over here you are asked to find out the intersection nodes. You are given the function prototype, public list node, get intersection node, list node head A, list node head B. And then you are having int len A is equals to 0 and len B is equals to 0. Len A denotes the length of the linked list A and len B denotes the length of the linked list B. List node current A is equals to head A, current B is equals to head B. Then after that you are checking while current A is not equals to null, you are having len A plus plus, and then you are having current A is equals to current A dot next. Then after that you are checking while current B is not equals to null, you are incrementing len B plus plus, and then you are doing current B is equals to current B dot next. Now after these two while loops, you have got the length of the linked list A and you have got the length of the linked list B. Again, what you're trying to do, you're pointing, you're storing current A is equals to head A. That means current A will be pointing to the head of the linked list A and current B will be pointing to the head of the linked list B. Now you are checking if length of linked list A is greater than the length of the linked list B. In that situation, as I stated, you are trying to advanced ahead that many number of nodes. And that is why you are having for int is equals to 0 less than len minus len bi plus plus. And then you're doing current is equals to current d dot next. Basically, you are trying to advance ahead the difference number of length between len a and len b, right? Otherwise, if len a is not greater than len b, that means len b will be greater than len a. So that's why you're having for int is equals to 0 I less than len b minus len a I plus plus, and then you're doing current b is equal to current b dot next. Otherwise, if linked list b is higher, then you are trying to advance ahead for the linked list b that many number of nodes time, right? Now what you are trying to do, as I had explained earlier, we are comparing whether those two pointers are same or not. While current is not equal to current b, then you are having current is equal to current a dot next, and current b is equal to current b dot next. Now ultimately at some point of time, if both of them will be equal, then you will come out from this while loop, right? And then you will be returning current a. That means at that intersection point, you will be getting those values. And then what is the time complexity of it? It is again maximum of m comma n, where m is the length of the linked list A and n is the length of the linked list B, and the space complexity will be big of 1.
So we can either return current of A or current of B, right?
Yes, you are correct. Yep.
But Ranjan, if there is no intersection point, then in this case, if we will return current, then
Yeah, let's say if there is no intersection points, right?
then it will
In
not
that
return null.
situation, what will happen? Automatically, this current A or current B will become null, right? Are you getting my point? Because current A dot next
Yes.
will automatically be null.
Thank you.
No, but Ranjan, if current A, I mean, the one of the linked list has a cycle, then how do we arrive at a solution? It will go in infinite loop, right? Or say both the lists have a cycle without any intersection point.
That's what I stated, right? If they don't have any common intersection point, this while current A is not equal to current B will continue. And ultimately, when both of them will be null, this condition will be
No,
will
but
become.
if current A and current B, if they are running in I mean, in a cycle, they won't ever be null, right? This will go in an infinite loop.
But obviously, it is making sure that it is not having any cycle.
Yeah, okay.
Don't assume that there is a cycle.
Hmm.
And even if there is, yeah, you can clarify that with your interviewer. But for this problem, there is no cycle. Even if there will be a cycle, in that situation, you'll have to break the cycle first. So in this situation, the thing is that these two are two different linked lists, right? And at any point getting intersected, and you need to return that intersection. Over here, there is no possibility of cycle. Is this problem clear to all of you? Anyone having any doubt? Okay, sounds good. It's clear to each and every one of you. That's wonderful.